Let's look at how to precisely calculate latitude and longitude on a map that doesn't give a lot of control points for it. This is a 7.5-minute quadrangle map, which means that if you look at the longitude, we go from 97 degrees, 52 minutes, 30 seconds in the east to 98 degrees in the west. We're increasing measurements towards the west because we're in the western hemisphere. For latitude, we've got 29 degrees, 52 minutes, 30 seconds north at the bottom, and at the top, we've got 30 degrees north. It's just kind of implied that it's north because the numbers are going upwards towards the top, and it's assumed that we're working in northwestern hemisphere. With this, we only have a few control points between these two edges. We've got all of these orange UTM lines and all of their labels. We're going to ignore those and just focus on the global coordinates. And let me highlight where those are. We've got this one right here and this one right here. So as we go from 97 degrees, 52 minutes, 30 seconds towards the west, we hit that 55 minute, 57 minutes, 30 seconds. Those are both 97 degrees carries through, and then 98 degrees on the far end. Ooh, my computer's being annoying. All right, and then if we look at the bottom, we have the same control points down here. So there's the 98, the 57:30, the 55 minute, and the 97 degree, 52 minute, 30 second marks. That's for latitude. If we look at longitude, we have, I kind of hit it right there, but we've got a 29 degrees north, 52 minutes, 30 second longitude marking. Let's do those as circles, just because. And then as we go up, we've got 55 minutes, still with 29 degrees, 57:30, and 30. I'm going to bold these little tick marks that go with each of these marks. That is the precise point of that latitude. Notice that there are some other tick marks, but they're not evenly spaced. I'm not 100% certain that those are part of the normal latitude-longitude system, so I'm only marking these points right here, trying to be as clean as possible. Okay. We have to treat latitude and longitude each separately, and we're going to calculate them a little bit like you would distances, and when you measure distances with the scale bar and use a proportion to figure out the real world distance of some other feature. We're pretty much doing the exact same procedure, but instead of using like a scale bar with kilometers, our scale's going to be in seconds of latitude or seconds of longitude. So to do this, I'm going to need a ruler. Now here I'm using a screen ruler. You'll use a physical ruler, but I'll try to walk through the process like you would measuring it with a ruler. And before we can do anything else, we need to know, where are we measuring? So let's pick a random point on the map. Doesn't matter where, as long as we can define it precisely. So let's do this point right here in the middle of the map. That's that intersection. Latitude's a little bit easier to do for me just because you're adding from below upwards rather than adding from right to left, and that just works out better for me. I'll explain what I mean by that in a moment. When you're doing latitude, first thing you want to do is figure out, where does my point lie relative to the y-axis. You might notice that the line is not precisely oriented with the orange lines. The orange lines are part of UTM. That grid is usually a little bit twisted relative to the global coordinate systems. As long as it goes through the line marking latitude at the same place on each edge of the map. That's the orientation of the line you want to have. And you want to make sure whenever you're drawing this line, as long as your map isn't twisted, if a horizontal line goes through both points, then your line should be at a perfect right angle to your left and right edge of the map. So I have that. I can see where it hits the y-axis there. And the way the proportion here works is that whatever distance from 55 minutes to this line, that proportional distance from 55 minutes all the way up to 57 minutes 30 seconds, that proportion will be the same as the latitude increase above 55 relative to using a scale of 2.5 minutes of latitude change from 55 to 57 minutes 30 seconds. So basically we're going to calculate out what is our scale bar for latitude and use that to figure out how much further past 55 is this point. And I'm going to set that up, show you that setup as the proportion, make sure I can have a visible text. There we go. Okay, so what we're going to do with our proportion, just as we would with the scale bar, we're doing measured distance in centimeters over real world distance, but instead of kilometers, miles, or feet, we are using seconds. And we're using seconds because it's easier to get an answer and then go from seconds to minutes by dividing by 60 than it is to get an answer in like tenths of a minute and then figure out what that is in seconds. It's not a clean calculation. And we'll get our line there between them because it's proportion. So each side of our proportion is going to have that basic setup. And on the left side, that's where we would normally put our scale bar. And the right side, we're putting the thing that we're trying to measure. I'm just changing the colors to make sure everything's visible. So on the left side, we want to make sure we're using the right side of our ruler. We're using centimeters on the ruler. We measure from the 55-minute mark. All the way up to the 57-minute 30-second mark. And we find out that that distance between them is 19.2493 centimeters. And the real world distance that represents is 2.5 minutes, but we want to convert that to seconds. So 2 minutes is 120 seconds, 60 plus 60. 120 seconds plus 30 seconds is 150 seconds. On the other side of this equation, what we need to know is how far from this 55 minutes to this point are we needing to go. So we're going to take our ruler, and instead of measuring all the way up to 57 minutes 30 seconds, we measure just to that line, which is 16.8414 centimeters. And we don't know what that is in real world distance yet. That's what we're going to be solving for. So I'm just going to leave that as an X. This is a proportion, so we need to cross multiply. On one side, we're going to get 150 times 16.8414. And we get 2526.21. And on the other side, we just keep our 100 or our 19.2493 x. Obviously, 0.2493 centimeters is way higher resolution than you can do with the typical ruler. So that's not something that you would actually measure that precisely, but on the computer, I'm just going to leave it as is. If you do it to the nearest millimeter or half a millimeter, you're good. So, in other words, the nearest tenth of a centimeter. All right, so we have that part. We now need to get x by itself. We're going to divide both sides by 19.2493. And we get 131.24, or we'll just round it to the nearest second, 131 seconds. Now, this is not a value of longitude, or sorry, value of latitude. This just tells us how far past the 55 minutes our point is. So what we want to do is go ahead and convert that into minutes and seconds so we can easily add it to 55 minutes. So 131, let's see, 120 seconds is 2 minutes. So we've got 2 minutes with 11 seconds left over. We then add that to 55 minutes, or I should be more complete. We add that to 29 degrees 55 minutes. And we find out that our latitude is north 29 degrees 57 minutes and 11 seconds, or pretty darn close to that. So that's our latitude for our point. We now do the exact same thing to find longitude. There's really not much difference other than keeping track of which axis you're on. So I'm just going to straight up copy all of this over. I don't think we need this, but everything else I'm just copying over. And we're going to plug in the new information into the same spots. So here we're measuring from, where's our point? Let me drop the guide so we know where we're going. Ooh, all the way over there. Let's do the northern part of the map because that is closer. We're measuring between 97 degrees, 52 minutes, 30 seconds west, 97 degrees, 55 minutes west, and 97 degrees, 57 minutes, 30 seconds west. And so first we're going to find our real world difference between our two latitudes, between our two longitudes. We know that the real world difference is 2.5 minutes, and the map difference appears to be 16.7284 centimeters. So I'm changing out the measured distance on the map between our two latitude longitude between our two longitude. And we're going to leave it as 150 because it's 2.5 minutes between them. We now go back and make sure that you're measuring from the smaller number, from the right side, that 55-minute marker, to our point. 3.8181 centimeters. And then all the math from here on out is the same. So we cross multiply, 3.8181 times 150, and we get 572.7. And that's going to equal 16.7284 x. We then divide both sides by 16.7284. And we get 34 seconds, which is just 34 seconds. There's no minutes involved with that. So here, what we're measuring past was 97 degrees, 52 minutes, 30 seconds. Sorry, stop that. 97 degrees, 55 minutes. And we added 34 seconds to it. And that gives us west 97 degrees, 55 minutes, and 34 seconds. So that's our longitude. We've got our latitude in north and our longitude in west.